Hello.
Hey, hello. How are you? This is Mark from IoT Barcelona.
Hey, Mark. This is Holger.
Hey, hello. Good to see you.
Wait,
How are you doing?
camera. 1 sec.
No problem. I don't have a lot of light today. I will try to turn off some light. Give me a sec. Hey, nice to meet you finally.
Hey.
After a lot of messages.
Can you hear me well with the microphone?
Yeah, I can hear you. Fantastic.
Okay, because I got a feedback from some guys on Discord that it sounds like I'm on a sailing turn sometimes. The microphone is oversteering, but it doesn't happen with other platforms. So, and I haven't used this one yet. So,
you never used Jitsi?
No, we haven't. We typically use.
Okay.
And with the corporates, it's either like Teams or
Zoom.
Okay.
If it's okay, after your conversation or your explanation, I will talk about the example that I built with Balena and IOTA, if that makes sense to you.
Yeah, of course. Yeah. Is there what is the order going to be? So I'm talking first, or the other one?
Up to you. So look, we have Paul here. Hey, Paul, how are you? You're mute.
Yeah, I'm mute. I'm doing good, and you?
Hey.
Good. So Holger, Paul, you're the speakers today.
Yeah.
So up to you the order. I don't know if you have any requirement, Paul, on your side.
No specific requirements, so I'm ready. I can pass in a second. No problem. Like you want.
And Mark, regarding the duration, so it's going to be like 20 minutes and then 10 minutes Q&A, or
usually what I like to do, it's like when it was physical, it was like 5 minutes presentation plus unlimited Q&A. So I was incentivizing speakers to do like a high-level presentation or getting into something very specific, and then open it, trying to let as much questions as possible open. But on virtual, it's a little bit tricky to do that. So I would say, like, let's make 10-15 minutes presentation, and Q&A should be unlimited from my side.
Okay.
Let's try to be nice so we don't go to sleep very late. But now let's see if people join, because almost 100 people sign up on the meetup. Let me.
Yeah, I saw that it greatly increased. Then we could have also done more promotion around it, like from IOTA side. So it would be like a lot of a smaller round.
Let me. All right. So let's wait 5 more minutes. I just sent a message. Okay. Let's see how many people join. So where are you based, Holger? You're in Berlin, in Germany?
I'm a bit more south in Bavaria.
Ah, in Bavaria. Okay, cool. I
Yes.
used to live in Munich. So.
Ah, cool. Oh, it like heavily snowed, I think like 3 days ago. I also saw that Spain is completely, has been like snowed in, right?
Exactly, yeah. Yeah, a lot of snow. Yeah, cool. And the IOTA Foundation, it's basically in Europe, or it's spread all around the world?
We are spread around the world. So we have a headquarters in Berlin.
Okay.
I will also come to that on the slides then. But we are like distributed over 26 countries, 18 time zones.
Wow, cool.
Yeah, so a lot of people working on one big vision.
Nice. Now I work at Balena, so yeah, it's as well remote company, and
you work there. Cool.
It's interesting to work on a worldwide company with a lot of time zones and so on, and asynchronous communication.
Yeah. And it's quite funny because due to the whole COVID disturbance over the past year, I saw a lot of my colleagues or former colleagues and so on and friends that they shifted or pivoted hard towards home office, whereas for us, as we are already used to work decentralized, barely anything changed in the daily work. I mean, we closed the office in Berlin, of course, but this affected let's say 20 people there, which already were free to come in and out as they wished. So we were quite unimpacted from the whole COVID or by the whole COVID changes.
And and how is it affecting to the IOTA cryptocurrency, the Bitcoin and Ethereum will run, or it's not affecting at all?
You can see that the alts are rising as well. And there are a couple of updates in the making. Of course, it could always be better, but we always also say that IOTA is not primarily a cryptocurrency, but is essentially doing it like vice versa. So to say, when normally you have a financial transaction and you attach a payload or a message with it, and then you pay fees for this financial transaction, we say, wait, you have to do it the other way around. So first build a highly scalable communication network which works secured by DLT, and then you can attach like a financial transaction. So this is also why we don't have any fees in IOTA. We are per transaction. So to treat it more as a trusted infrastructure in the end, which is highly scalable, and through which you can then enable micro payments of 0.001 cent and so on.
Mm-hmm. Okay, really cool.
And it took a lot of blood, sweat, and tears over the past years to get to this point where you say, because most of the token economics were based on you have to secure the network by fees, to make it unattractive for an attacker. And now we're coming to this dogma to say, wait, there's another way. You can essentially send for a flat fee or for zero fees. With an all-you-can-eat model, you can send as many transactions as possible. And essentially, by having a certain amount of tokens, you secure yourself an amount of bandwidth, which is minimal guaranteed in the network. Mm-hmm. And this is the very big change.
Cool. So maybe it's time to start. I don't know. We have 20 people here, so yeah, it's before the 5 minutes that I said, but it's okay if we start with you first, Holger.
Yeah, of course.
So let me do the introduction. So welcome to the IoT Barcelona. Nice to see, 20 people here. Hopefully we will see more in the next minutes connected. Happy New Year. I don't know if we can say this until the end of December this year. And welcome to the 51st episode of the IoT Barcelona. In this case, virtual again, and I think we will keep virtual for some more months. And luckily that this is virtual, we are lucky to have guests from France and Germany today, speaking about IoT and cryptocurrencies. Feel free to introduce yourself on the chat. And if you have questions, just ask away during their presentations. And then after the presentations, we can do the Q&A session. And yeah, today this is a topic that I wanted to do. Actually, one of the last meetups that we made, like physical meetups, like a year ago or so, it was I invited a friend who is an expert on blockchain, and he talked about the theory of blockchain and talk a bit about cryptocurrencies, but not focusing on IoT. So I wanted to celebrate an IoT. So cryptocurrencies that are using or are merged with IoT projects, and this is why actually a long time ago I contacted Holger on LinkedIn, and Paul will talk about as well about Helium cryptocurrencies. I don't know what else. I think it's all yours, Holger. You can start sharing your screen or whatever you want to do.
Yeah, thank you very much. So, hello everyone. Thank you for having me and for taking the time. I've prepared our deck about IOTA. If you do not know IOTA, then I think it's going to be some, enlightening 15 minutes. If you have any questions, feel free to note them down, write them in the chat, and then we can address them after the presentation. So let me quickly share my screen.
On the top left, will you share your screen?
I'm using the good
bottom left
browser client. Yeah.
Bottom left, sorry.
This should be good, right?
Yeah.
So you can see the screen?
Yeah.
Awesome. All right. Great. So yeah, introduction to IOTA. What is IOTA? We have a very strong vision. So essentially we are building IOTA. We have been saying for the Internet of Things, but IOTA in general is more of a multi-purpose protocol with the aim to digitally secure the connection between billions of people, machines, devices, and so on through, you can read it here, through a feeless and decentralized protocol. And now, of course, the question is what does that actually mean? And I will come to that in a second. So I work from Germany. My name is Holger Köder. I have a background with industrial IT. I worked at Siemens for 10 years and then for 7 years at Atos. The past 2 years at Atos, or the last 2 years, I worked at Telefonica as the CTO for the Atos Telefonica account. And then in 2018, I joined the IOTA Foundation and representing partnerships and project implementation there. So who's the IOTA Foundation? We were founded in 2017, and we are established in Germany, but we have employees from all over the world. So we are based in Berlin, but have 110 employees at the moment, spread over 25, 26 countries, always changing a little bit. We are a non-for-profit organization, so everything we develop is also open source. You can download it, you can use it for free, as everything published under the corresponding licenses, so GPL3 normally. And we are developing IOTA as a protocol to really enable a globally decentralized, so trust layer. So essentially a layer which is secured, or an IT layer which is secured by distributed ledger technology, which is very often said a blockchain. But essentially you have a distributed ledger technology, and then you have different technologies under that. One of them is the blockchain, and another technology is what we have been pioneering since 2015, where the mathematical model is different, which is called a directed acyclic graph, or a DAG. There's a bit of a difference between the two of those, which I won't go into too many details. The general explanation is that in a blockchain, you have blocks which are linked through a chain. This is why it's called the blockchain. And with a DAG, you have individual transactions being connected with each other, which gives a lot more benefits in terms of scalability. And we are establishing the software so that this model can be used in order, or by everyone, so that you have a global network essentially, which is always available and where you cannot change the information as well. So it can be used in different scenarios, to which I will also come in a second. Yeah, we have a very diverse and distributed team. You can see it here. 100 colleagues, 25 nationalities, and we're all bound by this vision in really creating this type of protocol, which the world hasn't seen yet. It's a complete novum. What we're doing is complete cutting edge, bleeding edge research towards technology. We also have one of the largest ecosystems in distributed ledger technology. If you look up IOTA, and we are seeing like a lot more. Oh wait, I think the webcam's also turned off. Sorry, I was a bit irritated because the light was off. So we have like a lot of companies building on IOTA. We have over 300 patents referencing the technology already. We're working very closely with universities. We have like an ecosystem fund. So if you want to build on IOTA or support us in doing this, then you can apply for it, for the ecosystem development fund. And we have a very strong community, which is something that I think is like very exceptional, because a community is typically something which you cannot buy, but what you have to earn. And this has been growing organically and steadily over the time. So it's very exciting. I think we can skip this slide. This is essentially just to demonstrate that we have been working with DLT and with blockchain since its inception, with Bitcoin and so on. And there were like a lot of drawbacks with Ethereum and Bitcoin and like many other technologies, because they essentially involve like a lot of fees and are not really like scalable. So if you're a bit into the whole crypto market, I think at the moment the Ethereum fee per transaction is something like $10. It always varies a bit between $3, $20. And yeah, this is essentially what you have to pay. And where we were saying, wait, there should be a better way and also a more scalable way. And then we started to develop IOTA also with the IoT in mind. So you can see it here. There are like a lot of devices which are already connected. You probably own already maybe Alexa, or you own like a smart vacuum cleaner or something like this. But essentially, due to the downsizing of technology itself, and at the same time, technology becoming a lot more powerful. So you can see like with the mobile acceleration, where Google has been cramping like a lot of voice recognition software from like 120 gigabytes in the cloud down to like, I think like 5 gigabytes on the phone. So a lot of intelligence driven through AI and so on, deep learning, is like executed like locally on the device itself, so you don't need a cloud anymore. So what we are seeing with more and more IoT devices being connected and always on is that they have a certain sense of intelligence already on board, which is continuing to grow. And then when you think of messages from Tesla, for example, where Elon Musk has been stating that as soon as the Tesla autopilot is ready on a level 5 autonomous level, so that essentially can handle every traffic situation by itself, Tesla also thinks of not actually selling cars anymore, but just like renting cars out. And then this is like a very good example. You can see it also with drones, that drones are starting to do like discoveries in warehouses. So they are starting to track inventory stock, just automatically flying, discovering barcodes. And this is like a very big trend driven to better technology, which is starting to catch on to more and more devices itself. And so the question is now, but what is happening when all of these devices are communicating and when they are starting to actually interact with other devices? How do you make this secure? Because there have been like a lot of hacks in the past, so where security has been siloed or where security hasn't been really like thought through, and then it got hacked and the whole silo was completely compromised. And so the question is like, when we are moving towards more autonomous machines with more intelligence, and these machines are starting to become more autonomous by themselves, it doesn't necessarily, or it also means that they have to adopt to certain market principles. So the Tesla car, for example, what good would it do if it can drive autonomously, but at the same time it would stand in a garage for 16 hours? When Elon Musk is going to send out these cars, he wants them on the road for 24/7. So this means these machines, they have to comply with market economic principles in the end to essentially earn money. And for that, they will need a sort of like an ecosystem. They will need to participate in the machine economy. So to understand who wants to drive from A to B, how can they interact with toll gates and so on, and how can they do this like in a very secure way so that you can be sure that this machine is really coming. Let's say you're a certain tire changing bot, or it's a certain sensor which is sending data from a smart city onto a network. And so that the question is like, how do you actually cover this in with the infrastructure? And there are like a lot of siloed infrastructures, what the big players are building with AWS, Azure, and so Microsoft, and so on. But the potential is essentially, quite scaring, I would say, because also if you think of clouds, then if this decision making is happening locally, the question is like, how do you use clouds, and do you trust the cloud itself, or how do you act in a peer-to-peer permissionless network directly with all the other participants in a secure way, like when you're keeping bandwidth in mind and the physical limits of the electromagnetic spectrum, so to say. Are there like better ways that we can interact directly with each other? And this was like one of the ideas how IOTA has been built. So like one of our core statements is that the existing infrastructure with cloud is not really ready for this data growth of the 21st century, and that for-profit companies are owning like a big part of this critical infrastructure. And the question is like, do you really want to send all your data to Google or to Microsoft and so on? And then at the same time also that no open source standard and development exists for this type of interoperability. So we are developing IOTA to cover those needs, and it's not necessarily for the machine economy, but you can think of it like essentially as a globally available network, which everyone can use. So to share health data, or like part of a COVID health passport, for example, it's something what we have been developing, that you can enable machines with wallets. You can enable machines with a digital identity. You can enable citizens with a digital identity. And you can essentially empower the people again to decide what data they want to share and to whom they want to share it, and at which point they want to redact this data again. So the whole development and idea goes very much beyond saying, oh, this is a cryptocurrency, like what I explained in the very first minutes. When you think of cryptocurrency and the existing protocols, they're like limited by certain infrastructures, but especially cryptocurrency has the problem that it's limited by a certain fee. And when you think of a global system where with data integrity, where like a majority, like a big value proposition is about having digital trust in this network and secure information and data because it's valuable at a certain point, then it should not be associated with fees. But first you need like a global communication network, which is completely secure. And then the fee aspect is like, or should be like, the payment aspect, or one payment aspect should be baked into the infrastructure itself. So the idea of IOTA is to say there are no transaction fees. So that's one of the design criteria. So there are no transaction fees, and you can utilize the network without any transaction fees. So you don't need to own cryptocurrency, which is like a major red flag for all of the companies around the world, because cryptocurrency is not regulated. You have to think how you hold it, how you manage it, and so you can use IOTA without owning cryptocurrency. This is a very big point. And essentially you can use it as well for microtransactions to send 0.001 cent without any fee to a recipient's wallet with the cryptocurrency, if you want to make use of the payment aspect. But essentially it's the only protocol in the world, when you think also of competitors and so on, where you have a zero fee aspect combined with the possibility to actually handle data-driven scenarios, which are purely based on data integrity, and there's no other technology which can handle this. So I'm trying to like wrap it up in the next 2 or 3 minutes. Yeah, this is why we invented IOTA. The network is called the Tangle. So you've probably heard of it. You can see it here, different than the blockchain. You have like transactions which are chained directly to each other. There are like a lot of like layer 2 protocols on it as well, or like layer 2 functionalities, what you can build on it. So certificates and audit trails, you have like a decentralized identity. You have secure data streams, which you can handle from a developer point of view. You have access and permission management, digital wallets. And the cool thing for IOTA is that you don't need to operate like a big node, but essentially that we are building it for IoT. So meaning when you think of a small sensor of ESP32, for example, that you can utilize IOTA to encrypt data and demonstrate data integrity directly from the sensor. You don't need to send sensor data to an IoT gateway or anything like this, and then the IoT gateway sends it out encrypted. But essentially, you can use it on a small device. You can secure the data directly on the small device with a fingerprint, so there's no break in the whole chain itself. The data gets encrypted on the small device, and then it gets sent through the IoT gateway or through Bluetooth or like through LoRaWAN, for example, as well. So IOTA is fit for LoRaWAN transactions, then to go onto the internet, and there it gets globally distributed, this type of information, and who has the key can then also access this type of information. Yeah, and we are doing this together with, let me just come here, with different industry partners. So we are working on standardization of the protocol itself. We have Tangle EE as the enterprise edition, so to have contributions from other companies as well to it. And we are working with like a lot of large companies, so ST, NG, Zurich Energiene, Trademark is Africa, Jaguar Land Rover, and like a ton more. So to demonstrate, when you think of a global permissionless protocol, how you can utilize this with new business models, with new user interactions, but also with new models to really secure your data as part of a, I would say, a larger data network and permissionless ecosystem with which everyone can directly interact and communicate without having to build these like one-to-one adapters between all of these companies. Yeah, so we're at 6:22. I hope I managed it in time. There are like some slides more, but I think we can also share the presentation. Also go to our YouTube channel. I will paste it in the chat in a second. There are like a lot of case studies, use cases, testimonials from partners around IOTA, a lot more information. And then I would say thank you very much. And if you have any questions, I heard like a swoosh. I think it was the chat. Then we can dive into this now. Thank you.
Thank you, Holger. By the way, can you get into one case study, the one that you think that represents more IOTA? Maybe because, yeah, just to clarify, yeah, just one specific use case.
So especially for IoT, I think this is quite nice. There's Project Alvarium, which is happening with Dell and the Linux Foundation, which is about creating like a larger decentralized data network to ensure like a trust score, or like to have a trust score together with data. So when you think of data being captured and then hopping over different points to say you have a certain edge device, then you have a router, then you have a gateway, then you have a server, then you have an application, and all of these chain is essentially adding some of the trust points when it can prove that, for example, the router had booted securely, when you ensure that the sensor wasn't tampered with. So that it still has like several checksums in place that which shows that it hasn't been tampered with. And so essentially every stage in these where the data passes through ensures that it hasn't been tampered with and proves this through digital signatures. And in the end, you can show that your data itself hasn't been tampered with, and that despite the whole chain, it's really from this provider where you are assuming it is from. And another one is from Jaguar Land Rover, to think of car wallets, but also how a car is interacting with its vehicle-to-X communications, and then say, all right, when the car is detecting like a bump in the road or bad road quality or certain traffic conditions, how to share this data securely with all the other cars, and then how to interpret this data again to have route optimization, or to say, all right, dear city council, please take a look at this road because it's like really bad, and we have the evidence data to back it up. And you can apply this to like a lot more scenarios, like e-health scenarios for vaccinations, or trial runs, or Trademark East Africa, where we are saying like how to enable small businesses to have like digital processes which you can trust immediately, so that the business itself can, like in this example, concentrate on their core business, like growing flowers, and don't need to take care about, okay, what are my different trade certificates in paper, how to make sure that they're not being forged, what type of partners, how do I get like my flowers to the Netherlands, for example, through the airlines, and essentially ensure like a smooth digital process, which is completely covered by one technology with which all of these partners in this value and business chain can directly interact with, and can make sure that the information there is really coming from these trusted partners. So they have like one infrastructure of trust to which everybody can talk, which is globally available, highly available, performant, and through which they can communicate and interact. And that's it, with 3 examples. I will paste the links into the chat.
Let me tell you one of experience that I have on IoT and blockchain plus agriculture, however, that it's interesting. Because, yeah, at some point, they were trusting each other, the partners on this project where I participated. But yeah, then you are saying, yeah, we are putting this because you don't trust each other. And they are saying, no, we trust each other. So it's a little bit tricky, to say, yeah, you are trusting partners, but you put this because you don't trust each other. And on the other hand, let me give you another
This is typically in a consortium. Typically in a consortium, we already have partners who trust each other. But if you think of a more automated economy, and also, for example, of more AI-driven decisions, then the next step would be, all right, what do we do with the partners which are not part of the consortium? Or is there like a way to avoid building these like one-to-one connections, or like electronic data interfaces between each of these companies in a single way? And then also, how would you do microtransactions? How would you do decentralized digital twins, for example?
Yeah. Mm-hmm.
So there's like a lot of usage potential for the future.
And one more philosophical question about that on agriculture. I remember that one of the things that we saw is that because everything was stored on a blockchain and was you couldn't change that, that could actually create a problem. For example, for the most poor people on the workflow, that was the people who was on the agriculture side, and it was like, wow. So let's imagine, if it rains that amount of liters per year, that means that the quality of the product will be less or will be more. So, hey, are they hacking the rain meters in order to get the exact rain, to have to prove and trust, and we all have to trust that the right rain per year. What do you think? You have an experience on that?
Yeah, we are working in exactly like this type of project with the German Ministry of Agriculture in the state of Hessen. It's quite interesting because they have like the same challenge, that there's like a big like a water line, And now the question is like, okay, which farmer took which amount of water from the water line? They all have like a schedule on paper, but you cannot really see how much each farmer took. And if you take it further, then if you think of it like, all right, we have certain ground sensors which are measuring the humidity and the fertility of the soil, together with the water distributed, you could enable like a higher sort of like farming amount. When you think of different crops which are susceptible to different temperatures. So if you have a crop in the summer which would dry out earlier, then maybe the farmer who has this crop should be able to water sooner in order to have less crop dying in the end. And these like farmers at the moment, they're noting it down on paper, then they're sending it in, then it's being typed into an Excel sheet. So there's like a ton of problems. And instead, when you think of, all right, we position ground sensors, which are capturing the humidity, you can already send those over LoRaWAN. So in agriculture, awesome. Send it over 15 kilometers. You need like one LoRaWAN antenna, which is super cheap to cover like an incredible radius of sensors. And then you have something for the insurances to say, hey, this was really the humidity in the ground. And this is like the curve, how you can see it and how you can align it to the weather data, how much rain fell. So this is trusted data. And the second point is we are utilizing like smart water clocks to say, this farmer has really taken out this amount, and then we can prove it. So he has to pay for exactly that amount. But also we made sure that he has been watering his crops in time, because we have real-time data showing that he can suddenly earn like 20-30% more, and to have like a more sustainable way of farming, to letting less agricultural crops die in the end. And this is something which is being pushed very hard in the area of smart farming at the moment.
Really interesting. Thank you. We have the first question from Paul. So what's the power consumption for a device that works with IOTA? I imagine that runs a client or an agent.
It's very small, yeah. So in IOTA, when you're doing one transaction, essentially you're confirming two other transactions. It's not a blockchain where you have like these miners. We don't have miners, so we have been distributing the work what a miner is normally doing for millions of transactions to each individual. It's also a bit of a like altruistic approach. So the more you use the network, the more transactions you are confirming, because you are confirming to other transactions. So also the energy you are using for it, at the moment we are using like a proof of work, but it's like more of a spam anti-spam mechanism, because IOTA is free of charge, so we need to avoid that someone is just loading the database to terabytes. But with the next the incarnation of the protocol, we want to get rid of the proof of work and implement another like anti-spam or congestion control mechanism. But so the energy amount is like very, very little. So it's really specifically designed for IoT. And when you think of like IoT devices, either they are hardwired. When you think of sensor tech, like window sensor or temperature sensor somewhere, and when it's not hardwired but requires a battery, then they are typically the energy, or distribution in place, like a small solar panel or like a piezo element or like a wind turbine, for example, that you can make sure that the battery is like lasting for 10 years. So it is very, very little energy consumption. It runs on ESP32 or Raspberry Pis, also without any problem.
Cool. And he is also asking, what's the size of data transmitted from the device to go into the Tangle or IOTA?
At the moment, it's like 5 kilobyte, which is huge, but we are refactoring the protocol towards like the new way. The new protocol will have like a lot smaller signatures, which will come out like in 2 months. So we just released the first testnet for it, which is a complete redo of IOTA based on what we have been learning. And in the future, it will be around about 350 bytes per transaction. And you can size up then the payload up to, I think, like 1.6 kilobyte.
Cool. And Alex is asking you, do you plan to integrate IOTA into cloud environment like Amazon or Google Cloud or something?
We are implemented in AWS. So on the AWS marketplace, you have like one-click installs for private tangles. So if you want to run IOTA in a private environment, then just click on the private tangle. Then you have like a full private Tangle. It calculates 10 hours keys and then essentially can use it with unique keys. Or you can set up the node software through AWS with one click. But the node software itself, it also runs on Raspberry Pis. So we have to see how this will develop in the future when traffic is ramping up. At the moment, it's running to a certain degree of transactions per second where the Raspberry Pis can keep up. But yeah, at a later stage, you might require like more powerful devices. And sorry, what was the question again? Like the initial question?
No, if you plan to integrate, yeah, you already answered that. Yes, that you are integrated with cloud providers.
Yeah.
Right.
Essentially, the whole
infrastructure providers.
Yeah, and to install our IOTA node is essentially like 4 clicks, copy paste with apt get and apt install. So 4 lines, copy paste the code on a Linux system, and then you have the node running.
Want to get introduced on IOTA? I just made, following the tutorial of the IOTA website, I just made this balena IOTA example, where there are several examples here, but actually with a Raspberry Pi 3 or 4 and an SD card and a Balena Cloud account that it's free, up to 10 devices, clicking deploy with Balena and getting like a receiving address and seat address that you can get from the tutorials. Actually, yeah, the tutorial link is here. You can start playing with doing transactions to the developer database from IOTA. I think this is the previous version, that you're working on a new version, right? But just if anyone wants to get introduced, I'm going to paste this GitHub account into the chat, so you all can play with it if you want in just one click, and just get into the files or get into the tutorial. We have another question. So Paul is asking you, is this data from devices stored forever on the chain, or there is a size required for a miner?
There are 2 aspects for IOTA. So the one thing is to use it as a communication protocol in IoT, so as the secure layer of trust. This is why we have a mechanism where you have essentially the whole data stream passing by the node, and where you can say, my node only retains the last 1 billion transactions, or maybe only the last like 10,000 transactions. So this is why it can run on small devices like Raspberry Pis, where the devices only need to like listen for a certain trigger event on the whole data stream, and then execute something based on this trigger. If you want to retain the data, this is also possible. So it's built for communication, and it also supports the whole data retention. For this, we have a Chronicle, it is called. It's a permanode, and this retains then all the transactions in the Tangle. So you can run this, because this would be used for, let's say, decentralized identity, because you don't want to issue a decentralized identity regularly on the node, on the network, just that everyone can buffer it. Or the same like with access and permission management rights. You want to send them out one time. So at the moment, we support like to store like as much of the past X transactions, how much you want, or to store everything. And we are working on a technology, which is a selective permanode, to say I want to keep only certain transactions which are relevant for myself as a company or organization, and I want to have like a cryptographic path to the latest state of the network through which I can still prove that my entry from the past is valid, but without saving all the stuff which is essentially not relevant for myself. So this is also one aspect where the whole directed acyclic graph comes in. And then we are working on smart contracts, digital assets, color tokens, and so on. So there's like a lot going on also behind the scenes. We are not there yet, but yeah, we hope to be there like very soon. And if you want to join the IOTA community, just hop on. I will also paste this in the chat to discord.iota.org. We have like a ton of project channels. It's an awesome community itself. And yeah, we hope to see you there, share the ideas, bounce the ideas, and then exchange.
Absolutely, yeah. Thank you. So if there are no more questions, let's jump into Paul to talk about another IoT crypto project. And yeah, I know Paul from a lot of projects. So yeah, Phil, if you have more questions for Holger, feel free to introduce them into the chat, and we can do at the end like a final Q&A, no problem. Paul, all yours. Actually, Paul doesn't work at Helium at all, so I actually convinced him. He's one of the most expert on Helium from my point of view today. So yeah, this is what I wanted to. We already had Helium before summer here, speaking about Helium on a Helium point of view, but I wanted to have someone who could talk about IoT, LoRaWAN, and Helium. So all yours, Paul.
Thank you, Mark. Do you hear me, and are you able to see my screen?
Sure. Yeah, we see your screen and we hear you well.
So cool. So I'm going to talk a bit about Helium. I'm not part of Helium, so I'm just a user of Helium. And I'm a blog owner on the isk91.com. So you can find some posts on my blog. And you can follow me also on Twitter, the isk_91. So what about Helium? Helium is a LoRaWAN network, a crowdsourced LoRaWAN network. So it means that it's not the network itself is not deployed by a company, but deployed by you and me. So anyone can participate and deploy this network. It's a network mostly built in North America. So there is about 15,000 hotspots deployed currently. And I think there is about 13,000 in North America or something like this. So it's really starting in Europe, but currently it's mostly North America. But I mean, in UK, there is a lot of devices. In France, about 20 or something like this. In Spain, I think it's about 22. in Germany, I think there is a bit more, but okay. So it's growing there. So it's a LoRaWAN network. It means that
69 they say in Spain.
Oh yeah. So it means that any device working on LoRaWAN, so working on TTN or working on any other LoRaWAN network, will work on Helium. So that's a cool thing. And the particularity of this network is that it works with a blockchain, and the blockchain is a way to create a revenue for people who are deploying the network. So it's really an Uberization of the telecom industry. It's not, I mean, TTN is the thing network. It's more open source mindset. So everyone deploying antenna just because they think it's cool, and they are happy to share networks for free with people. Helium is more, you can make money by deploying a network. So if you want to get some money, you could be interesting in Helium. So it's not targeting the same kind of people, basically. So here we are going to see how it works, basically. And so it works on with a blockchain, and so there is some transaction. And there is one transaction, two transactions that are really interesting, and we are going to focus on. The first one is the POC transaction. So it's a proof of coverage. So the purpose of the network is to provide connectivity. So connectivity is radio coverage. And so a transaction is to prove that you are delivering a coverage. And is it a large coverage or is it a small coverage? And so basically your revenue will be based on that coverage. So that's the first transaction. And the second one, which is interesting, but currently not the one to earn money, but later it's going to be the one to earn money, is transferring data. So like a telecom industry, classical business model for telecom industry, for every packet you are passing through the network, the device will pay for this communication, and the hotspot owner will get a share of this communication cost. So basically more coverage you have, more communication passing through your hotspot, and more revenue you can get from this solution. So there are the two main transactions with a business model for the hotspot people, deploying people. So to support this, there's two transactions. There is two different money, two different token. There is a crypto token. So the crypto token is the HNT, and this crypto token is created when you are executing transaction with a miner. So when you are doing POC, you get HNT, or when you are receiving and transferring data, you are burning the other money, which is a DC, and you are creating HNT with that. And the second money is the DC. The DC is what the device is consuming to perform a communication. So it's what the device is paying to the network for its communication. So if you want to get a DC, you have to burn HNT, and when you use the DC to communicate, they are burned for the HNT creation. So there is a